This video is a combination between the energy concept and collisions and work and energy theorem. And you now will instead of figure out the distance, you will figure out what the coefficient is, which is the opposite of what you just did from the second video. Same knowledge. So let's interpret this one. So this one, the box M1 is actually initially at rest. So you will write it down. I'm just gonna say Vm1 I is actually a 0. So what's given in this information was, when it goes out here, it gains the speed as the energy or as the potential energy changed to all the way to kinetic energy. So before it collides with this block right here, it has Vm1 final. It has the velocity of 3.5 v0 meter per second. So you are tasked to figure out what the height is. So let's make it easy, simple. So potential energy translated all the way to kinetic one. So it's mgh is equal to 1/2 mv squared. By now we should realize we should have seen these formulas coming for a long time. Okay, same as you're looking for the height, so this is how I would do it. 1/2 v squared divided by gravity. And then I'm just gonna go ahead and replace the number. 1/2, my final velocity is 3.5 square divided by 10. Let's do the math. This one, just go ahead and use the calculator. 3.5 square. The height is 0.6125 meter. That's the first question. You determine the height. And then for the second part of this one, so basically this one, the block M1 collides with M2, and then the information would say something like, it actually gives you the final information, like, is equal to 2 VO meter per second. That's initial velocity. That's the final velocity of the second block. And you're looking for the initial velocity of this one. So I'm just gonna say, looking for V1 final. Okay, so we have to use the momentum concept. M2 V2 is equal to M1 V1F plus M2 V2F. Let's interpret what's given. What information is given to you. At this point, just go ahead and plug in the values. This one is a 0 again because block M2 is at rest. M1, the mass is 5. The velocity is 3.5. M1, 5 velocity. That's what we're looking for. M2, the mass is 10. Final velocity is 2 v0. So basically, this is called elastic collisions, okay? Which is a little bit different than inelastic, in such a way that after collisions, both blocks do not stick together. They don't stick together. They don't combine. That's why I'm not combining those masses. So just do the math first. 5 times 3.5 is equal to 17.5, and that's 5 VF. 10 times v2, that's 20, plus 20v. And now what we will do was we will 7 minus 20 v is equal to 5 vf. So basically this is 2.5 velocity in that divided by 5. Which is 1/3. So basically, final velocity of the first one is equal to minus 1/2 initial velocity. So basically, after collisions, the block number 1, block M1, will travel to the left with 1/2 velocity. That's initial velocity. Okay, now let's go back to the last part of the equations. Since they don't stick, the only thing that happened is only this block right here, and eventually zero, because it will stop. Force times distance, remember? Okay, this is the force due to gravity, which is Fg, and that's the normal force. And the only force that actually acting upon this one is frictional force. If you were to put it that way, that one would be frictional force. And your frictional force is equal to mu n. Fk is equal to mu mg. Same thing, because they're on the surface. You have to have normal force, so 1/2 mv squared is equal to the force, which is mu mg d. Same as, get rid of it. So now you, instead of looking for the distance, you're looking for the coefficient. So I'm gonna leave coefficient here. These two I do multiplications, I'm gonna divide by that. So u mu should be 1/2 g distance. So that's your formula. So now I'm just gonna replace the number for the to figure out what the coefficient is. 1/2, my velocity is that velocity. 2 VO square divided by 10, that's gravity. Distance is equal to, let's look at the question, what's the, whether or not they will tell you what the distance is. The distance is, I'm just gonna put it like 10 meters. You either have the distance or you have to have coefficient in order for you to solve this problem. So your coefficient would be, you have 4 v0 squared divided by 200. Your v0, I'm sorry, your coefficient would be is this one, if this is the fraction. That's your coefficient that you're supposed to be looking for in order for you to solve this problem. So that's how you resolve the coefficient.